Alright, today we're going to go through the Unit 6 review. So we're going to start with number 1, a square and a trapezoid. So the first one is a square, so you should be looking for a lot of 45 and 90 degree angles. So if I look here, I know that all of these are 90, which makes y half of 90. So y is 45. X, the diagonals of a square meet at 90 degrees, so x is 90. And z, they're asking for a side, so we're looking at this right here. We're looking at this triangle. Both sides here are 10. Oops. So this is 10, this is 10. So to find z, we're going to do 10 squared plus 10 squared equals c squared. So we get 200. Square root of 200 is approximately 14.14. We're trying to find z though, which is just half of it. So we're going to divide that by 2. So z is equal to 7.07. Right, now we're going to move on to the trapezoid. The easiest one to find is x. They're corresponding angles, so 72 and x are the same spot, just different levels. So x is 72. Y and 72 are supplementary. Remember, opposite base angles of a trapezoid have to add to 180. So we're going to do 180 minus 72, which gets us 108. So y is 108 degrees. To find z, you have to remember that this is a mid-segment. So to get from here to here is 5. So to get from here to here, to get to the smaller one, if you went down 5 to get to 10, you're going to go down another 5, and you get z to be 5. Now we're going to move on to the kite and the parallelogram. So a kite, we know lots of things about a kite. The first thing you always want to do on a kite is mark that the diagonals are 90, just like a square and a rhombus. Next thing you want to look at is the non-vertex angles. So where the two congruent sides meet, this is called the vertex angles. This would be a non-vertex angle. Okay, what we know about those is those are congruent to each other, so this has to be 60 and y has to be 30 because they're congruent to each other. So 30 and 30, 60 and 60. The other thing we know is the non-vertex diagonal is bisected, so this chunk has to be equal to this chunk. So this would also be 3. Okay, and we know the other diagonal is 2 and 10, so that helps us. The next thing we're going to start looking for is triangles. So the first triangle we're looking at is right here. And get my highlighter. So we're looking at this triangle. Oops, not that one, excuse me, this one. To find x, so you would do 90 plus 30, which gives you 120, so x has to be 60 because we subtract from 180. Second triangle we're looking at is this one. So to find z, we're going to do 60 plus 90, which gives me 150, subtract from 180, leaves me with 30 for z. And the last thing we need to find is w. W is a side length. To find w, we're going to have to do 10 squared plus 3 squared for the sides because we have a right triangle here. So we get, 10 squared plus w, hold on, take that back, don't even look at that. We're going to get 10 squared plus 3 squared because we have 10 and 3 equals w squared. So I get 100 plus 9 equals w squared. W squared equals 109. So w equals the square root of 109, which is approximately equal to 10.44. Right, then we have our parallelogram over here. What we know about a parallelogram first is opposite sides are congruent, so we're just going to fill in this is 7 meters, even though we don't need to find this side, it's also 5. We also know that opposite angles are congruent, so x has got to be 142 degrees. And the last thing we know is that adjacent or angles that are next to each other have to add to 180, so y and 142 have to add to 180. So we're going to do 180 minus 142, which gives me an angle of 38 degrees. So y is 38 degrees. Right, and the last shape we have is a rectangle. Find my mouse. Right, the last shape is a rectangle. And what we know about a rectangle is that the diagonals are congruent, so all the pieces are congruent. So the nice thing is we formed a bunch of isosceles triangles here. Y and 40 are alternate interior angles, so that has to be 40. This whole angle is 90, so 90 minus 40 leaves me with 50. And then this angle also has to be 50. Now since I have a bunch of isosceles triangles here, this has to be 50 and this has to be 40, because base angles of an isosceles are congruent here. These base angles of the isosceles triangles congruent. These two are congruent, and these two are congruent. So then to find z, I just have to add up my triangle parts. So 40 plus 40 is 80. Subtract from 180 gives me 100. So that makes z 100 because these two are vertical angles. So x is 50, y is 40, and I forgot to put a space for z, but z is 100. AB is easy. Opposite sides are congruent, so that's 8 centimeters. And BD is a little tricky. Go back to my highlighter here. I'm looking at this triangle right here. So I know this side's 8, I know this side's 12, so if I'm trying to find BD, I'm going to use Pythagorean theorem. 8 squared plus 12 squared equals. We'll just do c squared, and when you do that you get 64 plus 144, which gives you 208. So when I square root it, I get the square root of 208, and which is approximately 14.42. Right, now we're going to move on to polygon properties. Oops. So it says find the number of sides in a regular polygon if the exterior angle is 36. So remember the exterior angle formula is 360 divided by n, and we set that equal to the degrees. We know it's 36 degrees. We don't know n because remember n is the number of sides. So to calculate this we just end up doing 360 divided 36, which should leave me with a 10-sided shape. Alright, find the number of sides of a regular polygon if the sum of the interior angles is 3,960. The formula we're using for the interior angle sum is 180 times n minus 2. We don't know the number of sides, but we do know that the angles all sum to 3,960. There's multiple ways you can go about solving this. A lot of people tend to distribute first. That's fine. So you get 180n minus 360 equals 3960. Add the 360 over. You get 180n equals 4,320. Dividing by 180. N equals 24 sides. So the shape we have here is a 24-sided shape. Right, a couple more about angles on the inside. So the next page we have find the measure of an interior angle, regular polygon whose interior angles are twice as big as the exterior. And I'm actually going to change this. We want to find the number of sides because that's usually what it's going to ask us to do. So I'm going to draw any polygon I want. So I'm going to draw a hexagon. Now I simply just need to extend one of the sides and I create an interior and an exterior angle. I'm going to call the exterior angle x because I don't know what it is, but I do know that the interior angle is twice as big as the exterior, so I'm going to label the interior as 2x. Now an interior and exterior angles always lie in a line, so they have to add to 180. So x plus 2x has to equal 180. So 3x equals 180. X has to equal 60. Now what that means is my exterior angle is 60 degrees, my interior angle is 120. Now that doesn't help me find the number of sides. Now I like to work with this formula, the exterior angle. So I would set 360 over n equal to 60. And you're going to really just divide 360 divided by 60 when you go to solve that. So n is equivalent to 6 sides. My thing's going haywire. There we go. Alright, Now, if you remember that 120 is the interior angle sum, then you should be fine, okay, of a hexagon. If you remember 120 is a hexagon, then it's fine, but if not, just use the exterior angles. Right, the next one says a rhombus has vertices 1, 2, and 5, 9. Find the slope of both diagonals. Now this should say a rhombus is diagonal, has 1, 2, and 5, 9. So if I draw a rhombus here to the best of my ability with this lovely thing. There's my rhombus. I have one diagonal here, another diagonal here, and notice the diagonals of a rhombus meet at a 90. So I'm working with perpendicular slopes. So remember the slope formula is y2 minus y1 over x2 minus x1. So if I label these x1, y1, x2, y2, I get 9 minus 2 over 5 minus 1, which gives you 7/4. So the slope of one diagonal is 7/4. The second diagonal is perpendicular, so remember we're looking for the opposite reciprocal. So the second diagonal has to be negative because it has to be opposite signs, and you have to flip it. So it's negative, oops, my thing is lagging here. Negative, just stop thinking, 4 over 7. Right. Oopsie. Right, oops, I copied that one twice. Alright, and the next one is pretty tricky if you haven't done a lot of these. Okay, so first it says find a point that would make a rectangle. So to do this, I need my marker. Actually, I'm going to use the straight line tool. So first I'm going to connect A to B, and then B to C. So that's what makes it start to look like a rectangle. So what I like to draw in is my triangle. I go down 2 and over 4. On this one I go over 1 and up. Whoops. Over 1 and up 2. So I'm going to count, if I count over 1 up 2 from this point, I have to count over 1 and up 2 from this one. And there's my last coordinate. If I were to connect those, I form my rectangle. Right? So the one that forms a rectangle is the coordinate, it looks like 2, 3. So over 2, up 1, 2, 3. Okay. Now the other one's a little bit trickier, so I'm going to scroll down here. Bear with me, I'm using a tablet and it's a little bit harder. So which of the points would make a parallelogram? I'm going to use my straight tool. Now before I connected A to B to C, now I'm going to connect A to C and then C to B. And I start to see half of a parallelogram. So it looks like my other points can be somewhere over here, because if I were to draw that in, it would look like a parallelogram. Okay? We're going to actually find the points. Alright, so I'm going to count my slope. So I like to go from the middle point and go down and over. So I go down 2 over 1. So from this point, I have to go down 2 over 1. And there's my parallelogram. Oops, wrong tool. So if I connect that, I get a parallelogram. So one coordinate that works is the point 0, -1. Right, now I'm going to do the same thing, but I'm going to connect it in a different order. Let's change this one to bright green so you can see it. So I'm going to connect, this is my new point, so I can't use that. So this is A, B, C. Now I'm going to connect this one to this point and this to that one. And I start to see a parallelogram form, and I'm going to bet that my point is somewhere over here, because if I were to draw that in again, I would get a nice parallelogram. Now I realize this one goes off your graph a little bit, but we can still work with it. Now what's easy about this problem is it's a straight line here, so you can just count how many you go over. So you go over 1, 2, 3, 4, 5. So from this bottom point down here, you have to match that. If you start at 5 and go over 1, 2, 3, 4, 5, you're going over 10 total. And it hasn't moved in distance, so it's still at 10 and it's still down at -1. So my last coordinate would be 10, negative 1, and that's what my parallelogram would look like. Now if I add the rectangle point to this, I'm just going to, ignore that. If I add the rectangle point, which is 2, 3, you should notice that your ending result is a big triangle, and each one of the points on the edge here are points that you calculated. So the second point that works is the point 10, negative 1. You should always get 3 coordinates that make a parallelogram. In this case, we have 1 that makes a rectangle and 2 that make a parallelogram. Okay? Gotta find my mouse. Hold on. Alright, so then it asks you to prove that your answer was a rectangle in the number 8. So I'm going to make my rectangle. Remember, it's the point 2, 3. So we're going to plot the point 2, 3 and connect it. So if I connect this to this, there's my rectangle. It's not perfect because I'm, again, using a tablet. Now to prove it's a rectangle, we have to prove they meet at 90 degrees. To do that, we're going to look at slope. So I'm going to count up and over on this one. Up 2 over 1. Remember, slope is rise over run. So the slope of A, and we'll call this point D, slope of AD is 2 over 1. Let me do the same to this one. It should be the same. I go up 2 over 1. So the slope of BC is also 2 over 1. Now we need to find the slope of the other ones. So I'm going to start at C and count up. So I go up 2 and over 1, 2, 3, 4. That's a negative because I went to the left. So the slope of CD equals rise is 2, run is negative 4. That simplifies to negative 1/2. Forget the negative. I'm going to do the same here. I'm going to go down and over. I go down 2, which is negative, and then I go to the right 4. So the slope of AB, rise is negative 2, run is 4. So I get negative 1/2 again. Now what you should write for your final statement, something along the lines of, since AD is 1/2 and CD, oh gosh, AD is 2, so we just found. AD is 2 and CD is negative 1/2. They are opposite reciprocals, so they are perpendicular. Then you could also make a statement about BC and AB being perpendicular. Then you could write, so BC and AB are perpendicular. And then lastly, you could write, since I have 4 90-degree angles, this is a rectangle. Right? So I think that finishes off, page 1 and 2. So I'm going to make a new video for pages 3 and 4. So continue on to the next one if you need some help. Again, just a reminder, perpendicular lines meeting at 90 degrees have to be opposite reciprocals. So 2 over 1, the reciprocal being negative 1 over 2. You flip it and you make it the opposite side.